Okay, so in this particular question, we're dealing with copper sulfate, which we've been told that the hydrated copper sulfate has got a mass of 2.31 grams, and once the water is removed, the new sample mass was 1.05 grams, and we need to find out the value of x, right? Now, what does the value of x relate to? The value of x effectively answers the question of, well, for every 1 mole of CuSO₄, how many moles of H2O are going to be in the formula here, right? So how am I going to work that out? Well, I'm going to want to compare the molar values, right? We've been given masses, so effectively this is a question which centers around figuring out molar values and also working with the ratios in a way that's actually useful for answering this question. So for CuSO₄, if I'm trying to work out the moles, and albeit in general, if I'm trying to work out the moles from a given mass, one of the key formulas is going to be that the fact that the number of moles n is equal to the mass m divided by the molar mass mr, right? So in this particular case, the number of moles for CuSO₄ is if you write that out, number of moles for CuSO₄ is going to be equal to the mass, right? And we're going to focus, because we're looking specifically at CuSO₄, we're going to look, what we're looking at is the anhydrous sample mass, right? So that's 1.05, and we divide that by the molar mass of CuSO₄. The molar mass is not given in the question, but we do have the formula, and so we can in effect use the periodic table to work out what the molar mass is. So the relevant elements here would be copper, sulfur, and of course oxygen, right? So, and I've got them here as well, just to make calculation a bit more straightforward to follow. So this is the molar mass of copper sulfate, so CuSO₄, right? So that's going to be in effect 63.5, right? So the relative atomic mass for the copper plus for the relative atomic mass for the sulfur, so 32.1 plus effectively 0.4, so it's going to be 4 times the relative atomic mass of oxygen, so 4 times 16, right? And so that's going to give us what value? Well, that's going to give us 159.6, and that's going to be in units of grams per mole, right? So over here, we can just write 1.05 divided by 159.6, right? And if you have a go at working out what that is, what you should find is that you get 0.0065789, right? And that's going to be in moles, right? Okay. Now, we also need to work out the moles that would be associated with the H2O, right? And we're not explicitly given the mass of the H2O, but we are told that, you know, the hydrated sample has a certain mass, the anhydrous sample has a certain mass, so we can infer from that the difference is the mass of the H2O. So what we can say is that the mass M of the H2O is the mass of the hydrated sample, 2.31 grams, minus the mass of the anhydrous sample, so minus 1.05 grams, right? And that's going to give us 1.26 grams. Okay, so the other thing we need to look at is in terms of N, so the number of moles N, right? So and this is specifically for H2O. So the number of moles for H2O is therefore going to be, of course, it's going to be the mass of H2O, so which is we've determined to be 1.26. So 1.26 divided by, as you can see in the formula up here, divided by the molar mass of H2O. So we need to work out the molar mass. So what's the molar mass for that? Well, simply that's going to be so MR of H2O. Just to get rid of confusion, that was not intentional to put. Okay, so that's going to be effectively for hydrogen, it's going to be 1 times 2, right? So 1 times 2 plus the relative atomic mass of oxygen, which is going to be 16, right? And that, of course, comes to 18, right? So it's going to be 18, and then the units of that is going to be grams per mole, right? So in this particular case, it's effectively 1.26 divided by 18, right? And that value is going to be 0.07, okay? And that's going to be in moles. Yeah. Okay, now although we've got molar values here, we for the purposes of trying to solve the question, we do need to compare them, right? I mean, if you look at the structure of the formula, we've got the we've got the sulfate, the copper sulfate on the left hand side, we've got H2 on the right hand side. So I'm going to set up a ratio comparison, and I'm going to kind of follow a similar structure. I'm going to put the copper sulfate on the left hand side, right? So so this is really the number of moles of CuSO₄ compared with the number of moles of H2O, okay? And so we've worked out what the moles are for copper sulfate here. So that's going to be effectively 0.0065789 compared to the number of moles for H2O, which is effectively going to be 0.07, right? And what we're going to do is, if we really think about the question we're trying to answer again, the question is, for every 1 mole of CuSO₄, how many moles of H2O is going to be, present in this hydrated sample? So we want the value on the left hand side for the CuSO₄ to be 1, right? And that's going to enable us to really answer that question. And so how are we going to do that? How are we going to get the this value 0.06 0.0065789 to be 1? Well, if we divide it by itself, then we are going to get to 1, right? So that's exactly what we're going to do. So I'm going to divide this by 0.0065789, okay? I'm going to do the same on this side over here. So 0.07, I'm going to also divide, but specifically because I've done it to the left hand side, right? So since it is a ratio, so what we do on the left hand side, we also need to do on the right hand side. So 0.0065789. So of course on this side, we're dividing that value by itself, so we're going to get 1. But on the right hand side, if you do have a go with your calculator and see what you get, what you should find is that on the right hand side, you're actually going to get 10.640. Okay, and at this stage, one of the things that's really necessary to do is, well, the value of x we're actually looking for is what we want is an integer value, right? Which 10.640 is not. And so what we're going to do is we're going to round this value to the closest integer value, which in this particular case we're going to need to round it up to 11, right? And on that basis, we're going to say, well, for every 1 mole of CuSO₄, what we're approximately going to get is 11 moles of H2O, right? So on this basis, what we can do is state that therefore the value of x is 11, right? And so the formula is basically therefore going to be CuSO₄ dot 11 H2O, right? Now, because we've made that determination, when we refer back to really what the question was asking here, to enter the answer in the space provided, what we can say is, well, the value to enter is going to be 11, right? Yeah. Okay, yeah.